So in the last chapter, we talked about how fats are hydrophobic, and instead of being absorbed immediately into the bloodstream, they have to be eventually transported. So that's where we're going to start here now. So our hydrophobic lipids being transported in the hydrophilic blood. And I think I just spelled that incorrectly. I need another L in hydrophilic. Oh well. Later. Okay, so lipids, again, being a very important, necessary for all cells of the body, but again, they're hydrophobic, so they're not going to dissolve in our blood plasma. So in order to take them after they've gone into our lymphatic system, and then they're being transported throughout the blood, they still have to have those vesicle packagings in order to transport the lipids, because again, your lymph is water-based, your plasma in your blood is also water-based, so your fat lipids, they have to be transported in their own little special packages. So these are called lipoprotein complexes. So they're part lipid, they're also part protein. So they're going to transport the lipids in our hydrophilic plasma. So the outside exterior portion of it is coated with proteins and phospholipids. This allows for the lipids to be suspended in the blood until they're able to be carried around. So this is also having a recognition marker. So in the cells that need it, ooh, I need that one. So kind of like if you've ever gone to, I know sushi restaurants do this, and I think there's a train restaurant that's like in Bryant or something. I don't know the difference between those two. Either way, where the food comes to you on a train. So same thing. These lipoprotein complexes, as they're traveling along, and it's kind of like the buffet comes to you. So the lipoprotein complex come through, that cell recognizes it, and it's like, oh, excuse me, I need some cholesterol, thank you. So you're able to get what you need and put it into the cell. Okay, so our serum lipoprotein, so these are packagings for our lipids into our plasma, so how we transport them around. So we have 4 different categories. We have our chylomicrons, so remembering as we absorb them from the small intestines, taking them into our lymphatic system, and then again, our lymphatic system is going to dump into our circulatory system, so into our blood vessels. So part of their being transported is the chylomicrons, so the smallest, and then we're going to go into larger structures. Next one is the very low density lipoprotein, even larger low density lipoprotein, and high density lipoproteins. So depending on what needs to be packaged and what is going on in the transport of the lipids determines which package you're going to have. Okay, so as we're transporting stuff, we're actually going to go through that whole process. So we're in the small intestines. The mice cells, so the mice cells have taken the fats from the inner lumen of the small intestines to our small intestine cells. Then those lipids are repackaged in your smooth endoplasmic reticulum, and then the Golgi packages them in the chylomicrons. Those chylomicrons, they get taken up by our lymphatic system to be dumped into our circulatory system, where in the blood capillary cells, the triglycerides that were packaged in our chylomicron, they're broken up into monoglycerides and free fatty acids. Again. Okay, so when they're broken up apart, then they are transported to our fat cells, where they're packaged in, they're put back together using the triglycerides. So they're using this very low density lipoprotein, so VLDL, as the package to go from the blood capillary cells into our adipocytes. So after we have dropped everything off from the adipocytes, the chylomicrons that we don't need anymore, those get degraded by the liver. Then you can reuse the pieces and parts. So therefore, they're not just being wasted or just circulating around. Okay, so the job of the VLDL is to take lipids to our adipose tissue. So from our circulatory system and into adipose, so they can be remade as triglycerides. These packages are produced by the liver. So once our VLDLs have done the job of dropping off the fats to the adipose tissue, they are still in our circulatory system and they become LDL. these LDLs can also be produced by the liver just by themselves. So just in case you don't need them for triglyceride, taking them to the adipocytes. Okay, so with these LDLs, which can be either just straight produced by the liver or they were VLDLs, they dropped off our triglycerides. So with our LDLs, they're having your packaging of your cholesterol. So remembering your very low density lipoproteins, they're going to be packaging all kinds of your different fats. When they drop off the triglycerides, you're still stuck with the cholesterol. So the cholesterol is what's going to stay in your bloodstream until you find a cell that needs cholesterol. Then that can be absorbed, and then the LDL can then be broken down so that you can release the cholesterol for the cell to use. So instead of taking lipids to a cell, there's another package that can pick up lipids. That package is called HDL, or high density lipoprotein. So they're also produced in the liver, but instead of being filled with something, they're empty. And they kind of circulate around through your bloodstream, and they pick up any kind of excess cholesterol or phospholipids from different organs. And then when they get back to the liver again, the excess cholesterol is put into your bile, and then that is removed off as waste. So that goes, to the gallbladder, and then during your digestion, that excess cholesterol and excess fats, they're also just dumped out as part of the waste product. So unless they get broken down or reabsorbed, they're coming out your back end. Okay, so the HDL, their job is to remove excess cholesterol. So what you're trying to do is maintain a regular cholesterol level of less than 200 milligrams per deciliter. So that's a good level of cholesterol. If not, they might put you on meds or wine. I had a friend like that. She went on wine for a little bit. She had like a glass of wine a day for, it's like a couple of weeks or at least a couple of months, something like that. Either way, whatever. Okay, so our body is actually able to make cholesterol. So our liver, yet another job, can actually make cholesterol for the body depending on how much we actually intake into our body. So if, let's say, you go on a breakfast eating spree and you got all this cholesterol coming in because you got French toast going, you got scrambled eggs going, you got all this cholesterol coming in, your liver is just going to back off on some of the production. So depending on how much your body takes in determines how much your liver needs to make. So looking at our serum lipoprotein levels, so again, this is something you can test in a blood test. So depending on your levels of LDL, so our low density lipoprotein, high levels of them is a warning sign that you could end up with cholesterol deposits in the artery. So basically filling in those blood vessels, making them smaller and smaller because they're filling up with gunk and they could possibly close off, causing you a heart attack. Okay. So these LDL levels are elevated in saturated fat intake because they're also going to have a fair amount of cholesterol. And then cigarettes, smoking, and coffee and stress can also increase your levels of LDL. So having that cholesterol just circulating out throughout the body. Okay, let's start this slide over again. Some random salesperson called me and I touched the wrong dang button. Okay, so with our lipoprotein complexes that are circulating throughout our bloodstream, so you can have levels of LDL is one thing you'll test for in, for example, a blood analysis test, so blood test, as well as your levels of your HDL. So high levels of LDL is a warning sign that you might have cholesterol deposits in your arteries, which help close them off, and you end up filling with your cholesterol and then possibly end up with a heart attack. Okay, so these levels can be elevated by saturated fat intake. So this type of diet would include a fair amount of cholesterol. So having those animal-based fats, because they also will come with cholesterol. Also with increased levels of cigarette smoking, coffee, and stress. The other package, so this is the package that's picking up excess cholesterol. So high levels of HDL is beneficial. So more of these packages picking up that excess. So these can actually help to remove them from the arteries. So increasing the ratio of HDL to LDL is very beneficial. So doing this through regular aerobic exercise, as well as avoiding smoking, saturated fats, coffee, and stress. And I put the laughing face on the coffee and stress because you're in college. Yeah, there's probably a lot of coffee and stress going on right now. Maybe you can use the other two. Avoid those. Okay, so let's keep going. So this slide kind of just shows you in picture form how we go through processing all of our fats. So we take in our fats through the diet, we break them down, we absorb them using chylomicrons into our lymphatic system, which takes it to the bloodstream. And then here, our lipoprotein lipase is going to remove the lipids from the chylomicrons, and then those chylomicrons can then go to the liver and just be broken up. The lipids that were removed are, excuse me, absorbed into our adipocytes or used by other cells. And then on this side, so part of our packaging of our lipids and taking them to different places. So your liver is making your VLDL, so our very low density lipoproteins that's going to have cholesterol and our triglycerides. So they can be taken up from adipocytes or from the bloodstream cells, and they take them to whatever cell needs them. You drop off triglycerides. Those VLDLs become your LDLs, and it's mostly cholesterol, and then the cells can then absorb that cholesterol from those LDLs. That means, you, again, high level, you don't want that because that means you got a high bunch of cholesterol hanging out in your arteries. Opposite situation with our HDL. So these are the shells produced by the liver to pick up excess cholesterol. So they go and do their thing and they circulate back around. And the liver gets rid of that excess cholesterol, part of your bile, which eventually you poop out. Okay, last macronutrient. We won't talk about water until chapter 23, I think. When we talk about acid, I think it's chapter 23. So, dealing with like the kidneys and our acid-base balance, so that section. Okay, going on to proteins. So, proteins, about 12 to 15% of our total body mass. Most of it is in skeletal muscle with a bunch of different functions, either for structure or for movements. Let's keep going. So, again, different versions of what our proteins do. So, with our proteins, we have 20 different amino acids that make up our different proteins. 8 of them are considered essential. So these are the ones we have to get from the diet because our liver can't make them. So it can't use the amino acids from other versions or other molecules, breaking them down and using them, creating the amino acids. Those, the 12 essential, we can actually create them. We don't need help. But for the 8 essential, those we have to take in through diet. Reason why we have to take in the amino acids because these cells do not cells don't store any excess amino acids. So the liver can store some amino acids, but regular cells don't. So in order to make sure that you have all the amino acids that you need to make protein, your cell has to have the amino acids on hand from your diet. So that's why you have to make sure that you are getting your essential amino acids. So, sources of our amino acids. So, our animal proteins are considered complete proteins because they're going to have all of the same amino acids in their proteins that we have in our protein. So, we're going to get all of at a minimum, our 8 essential amino acids. However, for plant sources, they're considered incomplete. And so, you have to combine different sources in order to make sure that you have all of your amino acids. So you can have complementary choices. Usually it's beans, nuts, legumes, and you pair it with some form of a grain product. So beans and rice is very common. Peanut butter and bread. Different sources, like you can do like legumes or beans and corn. Except for corns don't really have too much protein, but they do have that complementary choice, complementary pairing with the beans, nuts, and legume. It's a grain, but Yeah, it's kind of low on the nutrition value. Anyway, there are some complete plant sources that include soy products like tofu or tempeh, as well as quinoa, do have all of the essential amino acids that you do need. So depending on, let me see if you actually need this. Hold on. Okay, so depending if you are building body or not determines how much of what's called your nitrogen balance do you have in the body. So let's say your excretion exceeds ingestion. So you're getting rid of your proteins, so breaking them down exceeds your intake of proteins, like for example through diet. Sometimes this happens because your proteins are being broken down for fuel. So going back to grandpa who's not eating because he's tired of living, so that's why they start getting really super skinny, because those proteins are being used and broken down into a fuel source because they're not getting it from their diet. So this is what happens. The muscles atrophy or become weaken and become smaller. Okay, moving on to vitamins and minerals. So again, these are our micromolecules. You don't use them as fuel, but they're necessary for a lot of the different processes in the body. So I'm going to skip some of these. You do have different categories of vitamins, which are either going to be fat soluble or non-fat soluble. Okay, so water-soluble vitamins aren't stored. So these are the ones that you take them in and they're taken into the bloodstream. If a cell doesn't take them up, then they get filtered out in the kidney. So for example, vitamin C. I know sometimes when people get sick and then they start overloading themselves with vitamin C, yeah, all that excess is just going to pee right out, by the way. Okay, my little soapbox. Fat-soluble vitamins. So these are the ones we actually do store in the body because they're fat-soluble, which means wherever fat goes, this will go too. So these fat-soluble vitamins are stored in your fat, and that's just because that's what they dissolved in, so they just kind of hitched a ride. So A, D, E, and K, all of them are fat-soluble, and those are the ones we actually store. Okay, let's break down carbohydrate, but in another video because this is getting long.